Good day. So the new topic we're going to look at today is functions. It's related to algebra, as you'll see in a little while. And I just have a little definition here. A function is a process or relation in which each input, usually the x values, it has a specific name, the domain, which we'll look at a little bit later, and that's related to or would produce exactly one output or y value, which we'll call the range. So if the definitional word, you'll see it a little better when we look at some of the examples. So the examples we're going to look at f at x, and you realize they're using f because we call it function. So this is really a function of x going to produce y. That's the function of the input, again, that we call in x, going to give an output that we call in y. And we'll look at this in a diagrammatic form as well and see how it's related to graphing, because it is related to graphing as well. So f is for function, and then they use different letters of the alphabet. So we have two different functions here. We can call both f. So the first one, we start with f, and then g, and then so on. Sorry. So f at x is equal to 3x plus 4, g at x is equal to 2x minus 5. And what we're going to look at first is a different way to write this, because you won't always see it looking like that. Since it's related to graph, and sometimes in some years, for the exam, you might see it looking like this. F, two dots with an X and an arrow pointing to the function. Now this is read F such that X maps on to 3x plus 4. This means the same thing, and if you get this for the exam and it's a little confusing for you, you could rewrite it with the equal sign, as you'll see it's a little bit easier to use. Same thing for this one. Sometimes you might see G such that, that's what the two dots mean, X maps on to 2x minus 5. So if you see this in some past paper questions, that's just what it means, okay? It means this exact same thing, and you could write it back if you're more comfortable with that, because most of the questions will be written like that. So the first example, just to show you how it will work, I want to evaluate and work out not f at x, f at 2. So they give me f at x already, and I'm just going to write back f at x here to show you. That's f at x here, just for explanation purposes, I'm writing it back. And I want to input in place of x 2. So what all this really means is I'm going to replace x with 2, because I input in 2, because remember I say it's about input output. So I input in 2 in place of x. So wherever I see x, I have to replace 2. So because I'm replacing this x with 2, that means wherever I see x, I have to replace that with 2 as well. So that means this x is going to replace with 2. But this is not 32. 3x, if you remember algebra, when letters close to numbers, it automatically means to multiply. They won't write that for you. That's basic algebra. You have to remember that from before. So this really means 3 times I replace an x with whatever they tell me to replace with. So in other words, I input in x as 2 into this question. So I need to work out 3 times 2, and the plus 4 still there. 3 times 2 is 6, 6 plus 4. So my answer for this one is 10, meaning when I have an input of 2, the output or my y value going to be 10. Now they wouldn't expect you to put back y, that's the answer and question finished, but you can see how simple it is once you understand what you're doing. It was just substitution really. Let me look at the next example. Let me look at f at 0. So again, I'm still looking at the f function. I just writing this back for explanation purposes, but eventually you will need to write that. You can just look at the equation and pull that out yourself. So this is the equation, and I want to replace what I'm replacing x with this time, what I'm going to input. So in place of x, I'm going to input or replace x with 0. So that means because I'm replacing this x with 0, this x I have to replace with 0. So just like before, 3 times 0, anything times 0 is 0 plus 4. So my answer is going to be 4. When I input x as 0, the output or my answer going to be 4, the y answer. Similarly, we had two functions. We didn't look at the g function yet. We're going to look at the g function next. So for the g function, I want to replace g with 3, but this time I'm looking at the g function. So once I have more than one function, make sure you pay attention and don't input the wrong value into the wrong function. The g function is 2x minus 5, if you was to just double check there. And I want to replace x with 3. So if you want, you can pause the video now and try the question for yourself, and then unpause after and see how the answer is going to look. But I'm going to input x as 3 into the g function. So wherever I see x, I'm going to replace it with 3 in this question. So that means this x, again it multiplying, I have to replace with 3. So it's going to be 2 times 3 minus 5. So this is 6 take away 5. So my output or my answer going to be 1, and that's it, the question finished. Now you find this looking simple, but what's going to make it more difficult is you're not always going to have nice, neat positive numbers to deal with. You're going to have directed numbers, and that's what normally makes this a little more difficult, the directed numbers or the numbers with different signs. So here we're going to look at g at 1. So again, I'm looking at an xg function. Again, you don't have to do this part. It's just since it's the first time we're looking at this one, I want you to see it. Sorry, I write back the wrong function. So we have 2x minus 5, and again I'm going to replace x with 1, so it's going to be 2 times 1 minus 5. 2 times 1 is 2. 2 take away 5. Now even though we would have done this before, you need to know how to deal with directed numbers. What I'm going to get when 2 take away 5? I owe somebody $5 and I currently have 2, so if I pay them the $2, I'm still going to owe them $3. So even though it's simple, a lot of students make mistakes once the signs start to change, and you're going to have situations like this. But that's my answer. 2 take away 5 going to give me minus 3, and if you had your calculator to use, calculator might make it simpler as well. Let me look at the next one. We're going back to the f function. Again, the f function is 3x plus 4, and in place of that, I want to replace x with minus 2. So instead of having 3x plus 4, I'm going to replace x with minus 2. And I still have my plus 4. So 3, again, this is what x was plus 4, and this is what I need to work out. So again, with the directed numbers, you need to know how I'm multiplying a positive value and a negative value. So the nice thing is when I'm multiplying numbers, the value don't change. 3 times 2 is 6. What will change though, and what you have to determine, is the sign. So when I have a positive number multiplied by a negative number, the sign going to be negative. So I'm going to end up with minus 6 for 3 times minus 2. And I had my plus 4 waiting outside. And again, I have more directed numbers to deal with. I owe you $6. I pay you back 4. I didn't pay out all the money. If I pay you $4, I still owe you $2. So that's what will make this slightly more difficult, the directed numbers. But if you're okay with your directed numbers, then this shouldn't cause too much of a problem. But what I wanted to show you before we finish off this first part of functions is the diagrammatic representation. So this is not the diagrammatic representation. This is just a table form of it, a tabular representation. So if I want to do a table, which I could, for every x value that I input, so if I call in this side the input and this side the output, again, they have fancy names for them. We call it input, output, but the x values are normally really called the domain of the function. And the output values are normally called the range of the function. You would have probably see or come across those terms before. So domain and range is what they normally use for x and y, or input and output. So that's looking back at before, when I had input 2 into my function, which was the first example we did, the output was 10. So that's how I could do it in a table form. And when I have a x and y pair together, x and y pair together form a point, and I can actually start plotting the graph of this function now, because each time I put in an input and output, it's going to give me an ordered pair or a coordinate, and once I plot that coordinate, it's going to give me the graph of that function. These are linear equations, by the way, so it will be a straight line. All of that coming up in the topic that's going to follow this, coordinate geometry. So it's all related, as you'll see. All right, same thing, when I had input 0, my output was 4. So graphically, if I wanted to graph that, I take my x value and y value, and I get x is 0, y is 4. Same thing for the last one, minus 2, both of them turn out to be the same number. So graphically, I could start plotting that graph. Similarly, the diagrammatic representation I'm telling you about is called an arrow diagram. So in the arrow diagram, and normally the points will be consecutive, it wouldn't be all over the place like I have it. So I'll try and put it consecutive here. So this is what the arrow diagram going to look like. We will have our x values and either f at x or y values, or they might just put the function name, but they could put anything. They could put x to f at x to y, x to the name of the function, because realize all of these three things mean the same thing. F at x is really the y answer that's going to be output, is also the function name. So they could use any one of those here. So again, we call it an arrow diagram because we're going to have arrows shooting across to pair it up. So I'm going to do it in sequential order. When it's minus 2, it's producing minus 2, because again, that's my inputs, and it's going to produce the output or the answer that we're calling it. When I input 0, it's going to output 4, I just put them in order this time. When I input 2, it's going to output 10. And we call this an arrow diagram. And you'll see that sometimes in some questions. It's just a diagrammatic representation of the input-output process of the function, which is really just substitution, if you notice. Same thing we could do with g. We had 2 values for g, both of them on this page here. When g was 3, the outputs for y was 1. When g was 1, the output was minus 3. And if we want to do our next one quickly, let me just say I wanted to input 0. If it's easy enough, you could do it in your head. 2 times 0 is 0, because I replace an x with 0. So 2 times 0 is 0. 0 times anything is 0. 0 minus 5, minus 5. And again, just like before, if I wanted to plot this, so if I wanted points, I could pair up those two, just like we were doing for graphing in the previous topic. My first point could be 3, 1, 1 minus 3. And then I could plot these points, and you'll see that we get in a straight line. And you'll see that a little better when we're doing some of the graphs later for the straight line stuff. And again, if I wanted, I could do this as an arrow diagram. This time it will be x to 2x minus 5. Or if you wanted to say x to f, so g at x, or x to y, all of those will be fine, whatever you wanted to call it. And I could put in my values 0, 1, 3. When it was 0, my answer was minus 5. When it was 1, the answer was minus 3. When it was 3, the answer was 1. Again, that's what the arrow diagram would look like, the diagrammatic aspect of the function. So this was just a basic introduction to functions. This was the basic idea behind functions. They have 2 more pieces to look at though. Composite functions and the inverse function. We're going on to the intermediate one, the composite function, in the next video.